Hello guys, how are you today? So today I will be explaining the topics 10, the metals, only the questions, only the CQD. So this is the notes paper. If you open the SDP and you scroll into the chemistry in all weeks, you will find the notes paper of topic 10, the metals. So let's start with the first CQD. They said in part A, list 4 physical properties of alkali metals. We know, first of all, that alkali metals, they are soft metals, meaning they can be cut with a knife. Next, they have low density. Okay. Additionally, they have a low melting point and boiling point. And we know that they tarnish quickly on exposure to air. So again, for physical properties of alkali metals, they are soft, they have a low density, they have a low melting point and boiling point, and they tarnish quickly on exposure to air. Now, in part B, they said, why are alkali metals never found in their pure form? This is very simply because they are very reactive. So the more reactive a metal is, the less you will be able to find it in its pure form in nature. So we finished CQD number 1, we move on to CQD number 2. In CQD number 2, they told us, you are supplied with 3 samples of white powders and told that they are nitrates of lithium, sodium, and potassium. Explain how you would identify each one. You have to perform the flame test. So we are gonna perform flame test, okay? So as you know, the lithium, it will form an ion which is Li+, okay? And its color is crimson red. So on the flame test, its color is crimson red. Sodium, it will form ion Na+. It will give us a color which is yellow or orange yellow. Okay? Potassium, it is K+, okay? It will form a flame test which is violet or lilac. And that's pretty much it for CQD number 2. So actually, let me check. There's no more CQDs up. We will go down. And so we have CQD number 10. In CQD number 10, they asked what are transition metals. What you need to know on how to define transition metals, you can either define it based on its location in the periodic table. So you can say transition metals, okay? They are located between groups 2 and 3 or column 2 and 3, and they are metals that form at least one ion with unpaired d electrons. So this is one way you could define transition metals. Another way you could define them, that they are metals, okay, that form at least one ion. I wrote iron, oh my goodness, one ion with unpaired d electrons. Okay, so over here, they said what are transition metals. To define transition metals, we have two definitions. We have that they are located between groups 2 and 3, that they are metals that form at least one ion with unpaired d electrons. These are the two definitions you could use to define transition metals. So now we move on to CQD number 29. In CQD number 29, they told us list 6 characteristics of transition metals. Transition metals have 6 characteristics. 3 are physical properties and another 3 are chemical properties. The physical properties, we know that they are harder than other metals. They have a higher melting point and boiling point than other metals. They are denser than other metals. So these are the physical properties. Whereas the chemical properties is that they form colored compounds. Okay? They have more than one oxidation state. And finally, some of them have catalytic properties, meaning they can act as catalysts. So these are the 6 characteristics of transition metals. We will move on to CQD number 6. So here they told us, write the chemical equation for each of the following reactions. They said sodium metal with oxygen gas, magnesium metal with oxygen gas, and aluminum with oxygen gas. Okay, so in CQD number 6, they told us write the chemical equations for the following reactions. They want sodium metal reacts with oxygen, magnesium metal reacts with oxygen, and aluminum metal reacts with oxygen. You should know that the general equation of anything that reacts with oxygen, it is metal plus oxygen will give us metal oxide. Now we have what? We have sodium, which is Na, so it's going to be Na, which is a solid. It will react with O2, which is a gas, to give us what? The oxide. To find the oxide, we're going to take the ions, Na plus and O2 minus. We do the crisscross method to get Na2O. So the metal oxide, it is Na2O. As you can see, it's not balanced. To balance it, we'll put a 2 over here and a 4 over here. For the magnesium, Mg, it's Mg, which is a solid, will react with O2, which is a gas, to form, again, we'll do the crisscross method, Mg2 plus O2 minus, you will cancel the 2 and the 2, you will do crisscross, you will get MgO. So, as you can see, it's not balanced. To balance it, we'll put a 2 over here and a 2 over here. Now, finally, we come across what? Aluminum. Aluminum, okay, will react with oxygen to give us the metal oxide. So let us do the crisscross method. Al3 plus and O2 minus, crisscross, Al2O3. As you can see, it is not balanced. So to balance it, we're going to put a 2 over here, a 3 over here, and a 4 over here. That's it for CQD number 6. So we move on to CQD number 7. So here it said in CQD number 7, list some of the chemical properties of the alkaline earth metals. Say whether they react with cold water and how their reactivity varies down the group. Okay, this question is a bit confusing, but first of all, they said list some of the chemical properties of the alkaline metals. First of all, we know they are very highly reactive metals, but not as high as the alkali. Keep that in mind. Alkali is more reactive than alkaline. Alkaline is more reactive than transition metals. So, chemical properties, they are highly reactive metals. This is the first chemical property of the alkaline metal. So this is actually one of the only thing that you can write for now, because they didn't give us more information in the notes. Now they told us, say whether they react with cold water. So they do react with cold water, but we need to know that for the alkaline metals, they only use 2 metals, which is Mg, magnesium, and Ca, calcium. Mg will react with steam. Even though it does react with cold water, it will take a lot of time. That's why we use steam to react with the magnesium, whereas for calcium, Ca, we will use liquid water. Okay, which is cold, by the way. Now, how the reactivity varies down the group. As you go down the group, the reactivity increases. So down the group, increase reactivity. Now, other things they mentioned in the answer key was that you could write what? You could write they react with oxygen to produce metal oxide. So, first thing, you have that the alkaline, they react with oxygen to produce alkaline oxide or metal oxide. Okay? Then we have that the alkaline react with chlorine, which is Cl2, to form a solid metal chloride. So solid metal chloride. And then one more thing we can add is that alkaline will react with water, H2O, whether it's steam or liquid, to produce what? To produce either a metal oxide or metal hydroxide. So if it will react with steam, so H2O gas, it will produce metal oxide. If it will react with liquid water, which is cold water, it will produce a metal hydroxide. Okay, that is pretty much it for CQD number 7. We move on to CQD number 8. In CQD number 8, they said you are supplied with a sample of white powder and told that it is calcium chloride. Explain how you can identify the cation in the powder. This is all material from chapter 2, I believe. You're supposed to know their ions, their flame test, and all of this. You're supplied with a sample of white powder and you are told that it is calcium chloride. What is calcium chloride? CaCl2. Explain how you can identify the cation, which is Ca2+. You should know that Ca2+, when you do the flame test, okay, it will produce for us what? It will produce for us an orange-red flame. Orange-red flame. So that's pretty much it for CQD number 8. We move on to CQD number 9. They told us, write the equations for the reactions of calcium with water. Calcium, first of all, it is a solid. It reacts with water, but water, it will not be a steam, it will be liquid water, which is cold, to produce what? A metal hydroxide. Metal hydroxide, it is Ca2 plus OH minus. You do the crisscross method to get CaOH2. Okay? Which is an aqueous solution in addition to H2 gas. Now this is not balanced, so to balance it, you're just gonna put a 2 over here. This is for water. Now if we moved on to oxygen, it would be calcium, Ca, will react with oxygen O2 gas to form a metal oxide. Very simply, we're gonna take the ions Ca2 plus, O2 minus, we're gonna do crisscross, and we're gonna get CaO, and CaO is our answer over here, and it is gonna be a solid. As you can see, it's not balanced, so to balance it, you're gonna put a 2 over here and a 2 over here. Okay, now for part B, they said write an equation to show how lime water is used to test for carbon dioxide gas. State any expected observation. First of all, we know that it's lime water. Lime water, it is what? It is CaOH2 aqueous, so it is the calcium hydroxide aqueous. It will react with what? With carbon dioxide gas to produce what? First of all, we know that it will we know that it will turn milky, and when it turns milky, it will make a what? It will make a limestone. So limestone, you should know that its equation, it is CaCO3 solid, okay? And what's gonna be the remainder? It is gonna be H2O liquid. So you should know that lime water, which is CaOH2, will react with carbon dioxide gas to produce the limestone, which is CaCO3 solid, and H2O liquid. Okay, so that is pretty much it for CQD number 9. Now we will go down. We'll move on to CQD number 11. So here they said which metals react with water and which metals react with steam only. The metals that react with water, they mean by this cold water, they are what? They are K, potassium, Na, sodium, Li, lithium, Ca, calcium, and Mg. However, Mg, it's an exception because it will have a very slow reaction. Whereas the ones that react with steam, we have Mg again, magnesium, but this time it's a faster reaction. And then we have aluminum, and then we have zinc, and then we have iron. And then they said which metals do not react with water or steam. They are only 3 metals, I believe. They are Pb, which is lead, and then Cu, which is copper, and then Ag, which is silver. So now in part B, they told us the diagram below shows the apparatus used to test the reactivity of sodium, iron, silver with steam. Which of the metals can react with steam to form hydrogen gas? Based on what we discussed above, which of the following will react with steam or water? Steam or water will give you the same results, okay? To form hydrogen gas. First of all, we know that these 3 will not form hydrogen gas. So we look, which of these 3 is found here? Silver is found here. So for sure, silver, it is not gonna be able to form hydrogen gas. Whereas we know sodium and iron, they will for sure be able to form hydrogen gas. So the answer, it is E. We move on to CQD number 12. They told us which metals react with dilute hydrochloric acid. Here you should remember these metals. They are potassium K, sodium Na, calcium Ca, magnesium Mg, aluminium Al, zinc Zn, and iron Fe. They told us which are not able to react with 1 molarity of HCl. That means it needs to be more concentrated for them to be able to react. They are Pb, lead, Cu, copper, and Ag, metal. Okay, now we move on to CQD number 13. They told us the table below gives information about 3 different metals. We have metal P. Metal oxide is reduced upon heating with carbon, so it will react with carbon. Metal can react with dilute nitric acid. That means with a dilute acid it is able to react. So let us see. P, it's able to react with both. Q, it's only able to react with carbon. And then R, it's only able to react with the acid. So if we were to label them based on order of reactivity, okay, so now let us think of it in a theoretical perspective. Now, metal oxide is reduced upon heating with carbon. The term reduced means that it gains electrons. So if it gains electrons, that means it's not entirely stable. So if it reacted already with oxygen to form the metal oxide and it was stable, that means it was definitely the most reactive one out of all of them. Okay, so for now, we are gonna leave R as the most reactive one because it's not reacting with the carbon because it was very reactive. It reacted with all of the oxygen to form a very stable compound. Okay, now Q, it will not react with a dilute acid. That means it's for sure the least reactive, and that leaves us with P to be the one in between. So that means our answer from least reactive to most reactive, it is gonna be A. We move on to CQD number 37. Okay, so here they said the right equations for the reaction of aluminum with air. Okay, when aluminum reacts with air, they mean when it reacts with oxygen. So it's gonna be Al, react with O2 to form the compound. You should know by now how to make the compound. So it is Al2O3. As you can see, it's not balanced. So to balance it, you're gonna put A2 over here, A3 over here, and A4 over here. For B, we are reacting it with HCl. So aluminum will react with HCl to produce what? First of all, to produce hydrogen gas. This we know it. In addition to a salt. How do we know what the salt is? We're gonna take aluminum, Al3 plus, and Cl minus, and you'll do crisscross method. You will get Al3, not Al3, sorry, AlCl3. Another way you could understand it is that, look, Al, it forms a positive ion. H forms a positive ion, Cl minus forms a negative ion. So the positive is going to take the negative, and H will bond to another H to produce what? H2 gas. So now, as you can see, it is not balanced. So very simply to balance it, you're going to put a 3 over here, a 2 over here, a 6 over here, and a 2 over here. Now, finally, for part C, it is aluminum reaction with steam, which is gas water. So it's going to be aluminum, which is a solid. It will react with H2O, which is a gas, to produce, first of all, H2 gas, in addition to the metal oxide, which is Al2O3 solid. So as you can see, this is not balanced. To balance it, you will put a 3 over here, a 3 over here, and a 2 over here. So that's pretty much it for CQD number 37. Now let us go down, see if there's any more CQDs. Yes, there's CQD number 30. So in CQD number 30, they said most iron is extracted by reducing the iron ore, hematite by carbon monoxide in a blast furnace. What are the raw materials added to hematite in the blast furnace? We know that they are coke, which is C, carbon, calcium carbonate or limestone, which is CaCO3, and air, especially hot air. Okay, now in part B, this is very important. They told us a series of reaction occurs in a blast furnace during the extraction of hematite, iron from hematite. Describe these reactions. The first reaction is the combustion of coke. So we are going to combust coke to form carbon dioxide. So it's going to be coke plus O2 will form carbon dioxide. After that, we are going to reduce carbon dioxide. So reduce carbon dioxide. How does this work? We're going to add more carbon. So it's going to be carbon dioxide in addition to carbon will form 2 carbon monoxide. After reducing the carbon dioxide, we're going to reduce the hematite or the iron ore. So to reduce the hematite or the iron ore, it's going to be the ore, Fe2O3. In addition to this carbon monoxide, it will form what? 2 pure iron, okay, in addition to 3 CO2. Now, what happens then is that the decomposition of limestone, which is CaCO3, it will be CaCO3 will decompose to form CaO plus CO2, and then finally what's gonna happen is slag formation. And slag formation, it's very simply CaO plus SiO2, it will form CaSiO3. This is a solid slag, which is CaSiO3. It is a liquid. Now that's pretty much it for CQD number 30. We'll move on to CQD number 24. In CQD number 24, part A, what is cast or pig iron? Cast or pig iron, it is molten iron or pure iron, but it's preferable to write molten iron, obtained from the blast furnace. So obtained from blast furnace. Now for part B, what are the major impurities that it may have? First of all, the most major impurity, it is carbon. So 4% of the impurities, it is carbon. And then you will have other impurities such as sulfur, silicon, and phosphorus, but I don't believe they will ask us about it. But it's good to know that the major impurities, 4% is carbon. And then we have sulfur, silicon, and phosphorus as like aside, the other impurities. We'll move on now to CQD number 23. So they said, what two chemicals are essential for rusting to take place? We said rusting or corrosion. It is a reaction between the metal, okay, with oxygen in the presence of water. So the two chemicals essential for rusting to take place, it is oxygen and water. So again, corrosion or rusting, it is the reaction of metal with oxygen in the presence of water. Okay, so we will move down to CQD 33. They said list 3 methods to prevent corrosion of a metal. So the first method we have, it is the sacrificial protection. The second method we have, it is electroplating. And then the third method we have, it is galvanizing with zinc. So again, the first method we have is sacrificial protection, which is where a more reactive metal is gonna cover the iron. The second method we have is electroplating, and then finally the third method we have, it is galvanizing with zinc. We move on to CQD number 39. Here it says, aluminum is more reactive than iron. However, it's used in many applications such as satellite dishes and ladders without any coating or protection. Explain why. Here we had to discuss aluminum by itself. Why? Because since aluminum is more reactive than iron, it will react with oxygen directly to produce aluminum oxide that coats the metal. So aluminum coats itself by reacting readily with oxygen to form a layer of aluminum oxide. This is all you need to write and you are gonna get the mark. That's it. We will move on to CQD number 20. Here they told us list 3 uses of copper. 3 uses of copper we have is that you use them in electric cables. After that we have they are used in alloys and then in ornamental works such as so again, 3 uses of copper. We have electric cables, alloys, and ornamental works. I believe Alright, so now we will move on to the next question, which is CQD number 26. So for CQD number 26, which of the following statements describing alloys is false? Alloys are harder than the metals they are made of. This is actually true. Alloys are cheaper than the metals they are made of. No, they are actually more expensive. They are good conductors of electricity. This is true. They are mixtures of metals. This is true. They can be molded into different shapes. This is also true. So B is the answer. So now we will move on to CQD number 27. Part A. One of the alloys of iron is stainless steel. Stainless steel is more expensive than steel. It resists corrosion and is harder than it. It's harder than steel. Which of the following is made of steel? Saucepan, for sure it's made of steel. Cutlery, also for sure it's made of steel. Pipes in a factory, steel. Cooking utensils, steel. So we can say E, all of the above. Okay, then we go down to part B. Cutlery is made of stainless steel while food containers are made of aluminum. What is the property possessed by both metals that make them suitable for a specific use? They are good conductors of heat, I don't believe so. They are resistant for corrosion for sure. This is a good one. I think because we're dealing with food containers, they just need to be resistant to corrosion. That's the main thing. So now we move on to CQD number 31. Describe the structure of alloys. First of all, we know that an alloy, it's a solid solution of a metal with another metal or non-metal. So the atoms of the other metal or non-metal, they can either replace some of the host metals or they can occupy the spaces, or they can fill in the spaces of the alloy. Now CQD number 32. Why are alloys used instead of pure metal? Actually, we use alloys instead of pure metal because they have properties that we need that are not found in the pure metal. So properties not found in pure metals are found in alloys. Okay, so for example, pure gold is a soft metal and therefore it's not desirable when making jewelry. So gold is mixed with copper, forming an alloy that is harder. This is an example given in the answer key. Now we'll move on to CQD number 28. In CQD number 28, they said, draw a labeled sketch of apparatus that may be used to electroplate an object with silver by electrolysis. Write the equations for the reactions that will take place at each electrode. So I think, very simply, what we could do, we could draw the box like this. We can draw the, over here, here is the anode. And here, over here, it is the cathode, and this is the object to be plated, okay? Now, we are gonna plate this object with silver. So the electrolyte needs to be something silver. So we're gonna say like aqueous silver, AgNO3, for example. Aqueous. And then for the anode, okay, it has to be pure silver, pure Ag. And for the cathode, this is the object. This is all we need to know. Now, if we want to write the equations that will take place at each electrode, at the anode we have that Ag solid. At the anode it will undergo oxidation, so it will lose an electron, will become Ag plus aqueous plus E minus. Whereas at the cathode it will undergo reduction, so it will gain an electron, so Ag plus aqueous plus E minus is gonna give us Ag solid. So that's pretty much it for this question. We'll move down a little bit more. CQD number 35. Okay, so CQD number 35. What chemical is used to manufacture aluminum industrially? It is molten aluminum oxide. So what is the formula and common name of the aluminum ore? This is part B. The formula, it is a Al2O3.2H2O. and its common name is the common name of the ore, it is bauxite. However, the common name of the oxide, it is alumina. Okay, so keep in mind, bauxite is the common name of the ore, whereas the common name of the oxide, it is alumina. Okay, for part C, what is added to the aluminum ore to remove the impurity that's present along with it? You add NaOH because you're gonna remove the impurity, which is the iron oxide. Now, what is added to the aluminum ore to lower its melting point? We add the cryolite to it. Okay, what is the function of cryolite? Okay, cryolite is used to dissolve the Al2O3 as a solvent, and it lowers the melting point of the electrolyte or bauxite. I'm just gonna write bauxite. It lowers the melting point of bauxite. Okay, now part F, at around what temperature will the process take place? The process will operate at around 1000 degrees Celsius. Now finally, write an equation to show how aluminum is produced. Very simply, you will take the electrolyte or the molten, actually it's the molten form of the aluminum oxide, which is 2Al2O3 liquid. It will form us 4 aluminum, which is liquid, plus 3 O2 gas. So again, the equation to show how aluminum is produced, it's 2 of the molten ore, which is Al2O3, and then 4 Al liquid, which is the pure aluminum, and then 3 oxygen. Now we move on to CQD number 36. In CQD number 36, it says, aluminum is produced industrially by electrolyzing its oxide. What raw material is used at the electrolyte? What is the other raw material? It is used to lowering the operating temperature. Okay, at the electrolyte, we use something called bauxite. Okay, and what is used to lower the operating temperature of bauxite? It is called cryolite. By the way, bauxite, it is represented by Al2O3 2H2O. Cryolite, it is Na3Alf6. So keep these in mind. What type of energy is used in electrolysis? We use electrical energy. Okay. State the materials from which the anode and cathode are usually made. They're usually made of graphite, which is carbon. Okay. Now, why do they have to be continuously replaced? Because the graphite will react with the oxygen produced. So, graphite will react with oxygen produced to form carbon dioxide. So because of this reaction, we have to change it all of the time, or not all of the time, just like frequently. So now we move on to CQD number 38. Aluminum is extracted by the electrolysis of molten aluminum oxide, aluminum ore, dissolved in cryolite. A schematic diagram of the apparatus is shown below. Give 2 reasons why the electrolysis is done using a molten mixture of aluminum oxide and cryolite instead of solid aluminum oxide. Okay, so aluminum oxide, it is an ionic compound. First of all, you should know that aluminum oxide, it is an ionic compound. Because it is an ionic compound, it will not conduct electricity unless it is molten. So it needs to be molten to conduct electricity. Okay, so since the melting point of aluminum oxide is high, it is lowered by adding cryolite. So we add cryolite to lower melting point of the bauxite or the aluminum oxide, and then lowering the melting point allows to lower the cost of the extraction of aluminum. That's all of it for part A. For part B, give the ionic half equations for each of the reactions occurring at the electrodes. At the anode, which is the positive electrode, we will have oxidation occur, which is the loss of electrons. So it's 2O2 minus will form O2 gas plus 4E minus. At the cathode, which is the positive, not the positive, the negative electrode, which will undergo reduction. So the gain of electrons, it is going to be Al3 plus 3E minus to form Al. Now, finally, for part C, they said the anodes made up of graphite have to be replaced regularly. Again, we said that the carbon in the anodes react with oxygen to form carbon dioxide gas. That's pretty much it. Now we move on to CQD number 40, which I believe it is the last CQD for this question. Fill in the table to determine the property related to each of the given uses of aluminium. So, aircrafts or airplanes, we use the low density of aluminum because we need it to float in the air. We need it for the airplane to fly. Cooking utensils, it's a thermal conductor, okay? Because, for example, we need the pot for it to be cooked, okay? We need the heat to enter, so it's a thermal conductor. Wiring system, it needs to be electrical conductor and lightweight and malleable. Food packaging, it needs to be unreactive, meaning it doesn't undergo corrosion, and it will not react with anything else, and it's unbreakable. And then finally, for the building industry, it needs to be strong, lightweighted, and shiny. So I believe for now, under it, the applications, you can do them by yourself. It's not too much, it's like 8 pages. So thank you guys for watching. I hope you enjoyed and have a wonderful day.